Hey, hello friends, welcome back to the channel. This is Ahili Bhattacharya, your stats buddy, and today I'm going to do the questions of bivariate data analysis, which is unit 3. Now I'll start with a quick question. Have you ever looked at two sets of data and wondered, are they related? If I change one thing, can I predict the other? That's exactly what regression and correlation tells you, and which helps us understand basically. Today I'm going to break down these essential statistics concepts step by step using real world examples so you can not only calculate them but truly understand them. Stick around, this is going to make your stats assignments and data projects so much clearer, and I'm very much sure that this video will help you for your upcoming exams. Okay, now let us start with our first question. We're gonna have various variation of questions. Okay, see, the first question is a classic example: cost versus sales. We want to know, do higher cost leads to higher sales? To measure the strength and direction of this relationship, we use the correlation coefficient, often called R. See the formula: R is equals to covariance xy divided by sigma x into sigma y. This formula might look scary, but let's break it down. Covariance xy is the covariance. It measures how much x and y vary together. Sigma x and sigma y are the standard deviations of x and y individually. Now let us see the procedure. Procedure is, we first jot down the values of x and then the y, and then we need the mean of x and mean of y. How will we calculate the mean of x? Mean of x is equals to summation of xi divided by n. So we sum up all the values of x, which is 180, number of elements 9, so is equals to 20. Same for y bar is equals to 360 by 9, which is equals to 40. Now we do what? We calculate the deviation of each point from the mean, which is xi minus x bar and yi minus y bar. How to calculate xi minus x bar? It is 14 minus 20, which is minus 6, 19 minus 20, which is equals to minus 1, and we will fill up the whole of the table for both these columns, xi minus x bar and yi minus y bar. Then we multiply these two columns, xi minus x bar into yi minus y bar, and then we have all these values. Then we sum up all these values, which is the summation of xi minus x bar into yi minus y bar, which is equals to 193. Then we make another two columns of xi minus x bar whole squared and yi minus y bar whole squared. Okay, and then we also add up these values, which we get as summation of xi minus x bar whole square is equals to 120, and summation of yi minus y bar whole squared is equals to 346. Why do we need these two values? We need these two values for the standard deviation. All right. Now see, how to calculate the covariance of x and y? Covariance of x and y is equals to 1 by n summation of xi minus x bar into yi minus y bar. This is the formula, and we already know the value of this xi minus x bar into yi minus y bar summation is equals to 193. So we put the value here 193, and we get the covariance of x and y, which is 21.44. Now we calculate the sigma x square. Sigma x square, the formula is 1 by n summation of xi minus x bar whole squared. Now we know the value of summation of xi minus x bar whole squared, which is 120, and we put the value here 120 by 9, which is equals to 13.33. But in this formula, see, a sigma x and sigma y is required. So now how to get sigma x? We will just square root of this value 13.33, then we get 3.65, and we do the same for sigma y square. All right, and we get the answer of sigma y to be 6.2. See, now rxy is equals to covariance of x and y divided by x, sigma x into sigma y. And we know all the values. Covariance of xy is 21.44. Sigma x is equals to 3.65, sigma y is equals to 6.2. We put the values and we get the answer to be 0.94. Now see, this basically means, what does this 0.94 means? This tells us that there is a very strong positive correlation between cost and sales. As cost increases, sales tend to increase as well. Now see, coming to the next question. To obtain the two line of regression and estimate the likely demand when price is rupees 20. Here the data set is given, the price x is given for all the values, and demand y is given. What is the interpretation of this question? Price is given, so x is given, and we need to find the demand, so y is to be predicted. Therefore, we need the equation y minus y bar is equals to byx x minus x bar. So y is equals to byx into x minus x bar plus y bar. Now byx can be calculated by the formula covariance of xy divided by sigma x square. Now see, covariance of xy, the formula is we have just calculated 1 by n summation of xi minus x bar into yi minus y bar, and sigma x square is equals to 1 by n summation of xi minus x bar whole square. Now we make the table. We jot down the values of x, see here, and jot down the values of y, see here, demand y. And then what do? We take again the deviation from the mean of the points of x and y, xi minus x bar 10 minus 13. We of course calculate the mean first. X bar is equals to summation of xi divided by n. Then 78 by 6 is equals to 13. Then xi minus x bar is 10 minus 13 is equals to minus 3. 12 minus 13 is equals to minus 1, and so on for the whole table, for whole column. And same for yi minus y bar. And then we multiply these two columns, xi minus x bar into yi minus y bar. We fill up the column and then we add all these values. Then we get summation of xi minus x bar into yi minus y bar is equals to minus 6. And then we square all the values of xi minus x bar whole squared in the column of xi minus x bar whole squared formula. Okay, not the formula, the column. So here the column is 91194, and we add these values to get the, this will be helpful for the standard deviation of x, and this will be helpful for the standard deviation of y. Now see, covariance of xy, the formula is this 1 by n summation of xi minus x bar into yi minus y bar. Now we already have minus 6. This is the summation of this whole part, and n is what? N is 6, right? So answer of covariance of x and y is minus 1. Then sigma x square is equals to 1 by n into summation of xi minus x bar whole squared. So 1 by 6 into 24, see here. Summation of xi minus x bar is equals to 24. So here we put the value and we get summation, not a summation, summation sigma x square is equals to 4. Then byx, what is byx? Byx is equals to covariance of x and y divided by sigma x square, which is equals to minus 1 by 4. See, covariance here, the answer is minus 1, and sigma x square is 4, so minus 1 by 4. Now we need to calculate the likely demand when price is rupees 20. When price is rupees 20, we need to find y is equals to byx into x minus x bar plus y bar, because we need to find the y, right? And x is given, x is 20. So is equals to minus 1 by 4 byx into 20 minus 13. 20 is the price given here. Minus 13 is x bar. See, x bar is 13, and plus 41 y bar is 41. See here, and the answer comes to be 39.25. Now what does this 39.25 means? So the price of 20, we expect to sell about 39 units. Now we need to find what are the two lines of regression, x on y and y on x. X on y here means that y is given and x is to be predicted. Then the formula of the regression equation is x minus x bar is equals to bxy into y minus y bar. From here we get the equation of x is equals to bxy into y minus y bar plus x bar, and bxy is covariance of xy divided by summation divided by sigma y square, and sigma y square is equals to 1 by n summation of y minus y bar whole square. All right, so sigma y square is equals to 1 by n summation of y minus y bar whole square. Here the formula, the value which we got is 50, so we put the value here 50 and we get 8.33. Then bxy is equals to minus 1. See, the covariance, the value was minus 1, so minus 1 divided by 8.33, which we get as 0.12, minus 0.12. Then we put minus 0.12 in the value here bxy and get the equation of x to be is equals to 0. Minus 0.12 y plus 17.92. All right, now we calculate the equation, regression equation of y on x with the formula y minus y bar is equals to byx into x minus x bar, and we get the regression equation of y is equals to minus 0.25x plus 44.25. All right, now coming to the next type of question. This type of question includes giving the regression, giving the equations, and we need to find the mean from these equations. All right, we are not given any data set, the values. All right, so see, the data given here are two equations. First, we need to rearrange it, like 2y minus x is equals to 50, 3y minus 2x is equals to 10. So then we need to multiply equation 1, this equation, with 2. Why? To match with the coefficient of x in the equation 2. We used to do this in our school also. All right, so this is a very easy thing. Now we need to find the value of y from here. So 4y minus 2x is equals to 100, 3y minus 2x is equals to 10. And from here we get the value of y, which is equals to 90. And from equation 2 we can get x also by putting the value of y here. So x is equals to 130. The two regression coefficients meet at 130 and 90. So mean of x is 130 and mean of y is 90. Now let us assume that equation 1 is the regression equation of x on y, or y on x, whatever I've written. See, the equation 1 is 2y minus x is equals to 50. So we will assume that this equation 1 is the regression equation of y on x, which basically means that we need to find byx. So 2y minus x is equals to 50, then y is equals to 25 plus x by 2. The coefficient of x is byx. Okay, so byx is equals to 1 by 2. Now let the equation 2 be the regression equation of x on y. Then we find the coefficient of y here. Here the coefficient of y is the bxy. So bxy is equals to 3 by 2. Now we need to find the r is the correlation coefficient, the main thing which we were asked. Okay, so r is equals to root over byx into bxy. We get root 3 by 2, which is equals to 0.866. Now see, r is equals to 0.866, which lies between minus 1 and one of the regression coefficient is greater than 1 while the other is less than 1. So we can say that our assumption is absolutely correct. Now coming to the next question. See, in this question we need to find the two correct regression equations. So that means that we may find it wrong also. Then now we will learn in this question how to deal if we think that this assumption is wrong. See, we also need to find the x bar and y bar and the correlation coefficient, and the most likely value of x and y is when y is equals to 12. Okay, we need to find the value of x here, not y. All right. Now first let's start with rearranging the terms. 20x minus 9y is equals to 107, which is equation 1 we have named. And 4x minus 5y is equals to minus 33, which is equation 2. Now we need to multiply equation 2 by 5 because we need to match with the coefficient of x here from the first equation, and then from here we get the value of y, which is equals to 17. Now if we put the value of y in equation 2, we get the value of x, which is equals to 13. Now let us assume that equation 1 be the regression equation of y on x, which means we need to find byx. Then what is the coefficient? The coefficient of x here, 20 by 9. So byx is equals to 20 by 9. Now we need to let that equation 2 be the regression equation of x on y. Then we need to find bxy. So what is the coefficient of y here? 5 by 4. So bxy is equals to 5 by 4. Now let us check if we did it correct. R is equals to root over bxy into byx is equals to root over 5 by 4 and 20 by 9. So is equals to 5 by 3, which is equals to 1.66. But correlation coefficient always lie between minus 1 and 1, and here our answer is greater than 1, so our assumption is basically incorrect. So how do we proceed after that? Then what we need to do is now assume that equation 1 be the regression equation of x and y. We just do the opposite. Okay, so we need to find the bxy from equation 1. So basically the coefficient of y is bxy, which is 9 by 20, and for the second equation we need to find, let it be the regression equation of y on x. So we need to find byx, which is the coefficient of x, which is 4 by 5. So byx is equals to 4 by 5. Now let us check again. R is equals to root over bxy into byx is equals to 9 by 20 into 4 by 5, which is equals to 3 by 5, which is equals to 0.6. Now r is equals to 0.6 and it lies between minus 1 and 1. So we can say that our assumption is perfectly correct this time. Now we need to find the most likely value of x when y is equals to 12. So y is given and x is to be predicted. Then we need to use this equation. 20x minus 9y is equals to 107. Okay, see, if we put the value of y here, we get the x is equals to 10.75. So when y is equals to 12, the x's value will be 10.75. All right, now coming to the next type of question, which is the most important type of question, and I must tell you that in your question paper, if you understand this topic, you will have at least one question from this one. Okay, one is the untied case and another one is a tied case. First let's start with the easiest topic, but you need to understand it with focus. Okay, concentrate while doing this, or else if you get one value wrong, the whole thing will be wrong. See, the untied case is the easiest case of rank correlation. Here the question is, see, to find the Spearman's rank correlation coefficient and interpret the result. See, the data given here is reasoning test marks 20, 50, 28, and like that, and aptitude test marks. Okay, here what you need to do, first you need to know the formula is already you know from my previous video, which is for the untied case the formula is rho is equals to 1 minus 6 into summation of di square divided by n into n square minus 1. What is di is the rank rx minus ry. Rx is rank of x and ry is rank of y. Okay, and summation is I running from 1 to n. Now see, we jot the values of reasoning test as xi and we jot the values of aptitude test as yi. Okay. Now we put the rank. Now see this very carefully. The highest rank is 90. The highest value is 90, so the rank will be 1. Then the next value is 76, so the rank will be 2. The next value is 70, the rank will be 3, and so on. To the last value, which is 19, the rank is 11. Alright, and we do the same for yi also, which is the aptitude test. And then we do calculate the di, the values of di, which is rx minus ry, which is 10 minus 11 is equals to minus 1, 4 minus 4 is equals to 0, and we fill up the whole column. And then we do the di square, which is minus 1 whole square is 1, 0 square is 0, 1 square is 1, 0 square is again 0, and like this we fill the whole table. And we also do the summation of di square, which is equals to 22 here. Okay, do not worry because you will have a calculator to calculate all these values. Now here n is equals to 11 number of elements. Now let us calculate it. We put the values in the formula C 1 minus 6 into summation of di square. Summation of di square is 22. N is 11, so 11 cube minus 11. Okay, and the answer we get is 0.9. See, the ranks on both the tests are strongly positively correlated, so anyone performing good in reasoning test will most likely perform good in aptitude test also. Now coming to a critical case of which is a critical case of rank correlation, which is tied case. This is also very easy, but you need to have very much focus on this to understand it. Okay, and but this is very easy and this will come in your exam. Okay, one of the two cases will come in your exam and you will get 5 or 10 marks from this. See, find Spearman's rank correlation coefficient, tight case. Data set given is 1 to 10. Candidate is 1 to 10. Marks in mathematics is 52, 94, 72, and like that till the candidate 10. Then it is marks in statistics. We have all these values. What are the formula? Formula is tx and ty. Tx is 1 by 12 summation of t cube minus t, and ty is same. Okay. Now just because there are two categories of mathematics and statistics, I have named this as T and Ti. Okay. Now see here. This is the original formula. This is the correction factor, the Tx and Ty. Basically, the formula is same. See, rho is equals to 1 minus 6 into summation of di square plus Tx plus Ty divided by n cube minus n. N is the number of elements. Alright. As like the previous formula. See here very carefully. Here first we jot down the marks in mathematics as xi values, alright, and then yi values are the marks in statistics. Now see how will you do this. The highest mark scored here is C 94, 94, and 94. So, what will be the value? Which one will you give the number one position? You don't know, right? So, just randomly put 1, 2, and 3. Okay, and then average it. 1 plus 2 plus 3 divided by 3 is equals to 6 by 3 is equals to 2. Then you need to write the rank of these three values as same 2, 2, and 2. But you need to remember what you did last, what rank you used last, which is 3. Then the next highest value, which is 4, will be given to the next highest value, which is 72. The rank will be 4. Okay. Now see, these things which I have written in red color is not to be shown in fair. You need to do this with pencil and then erase it. Okay. This is something to be done in rough work. Now see, this is the fourth rank. Now next is number 5. Number 5 is 70. The next highest value is 70, so the rank is 5. The next highest value is 60, so the rank is 6. Now the next highest value is 52 and 52. We have two values. So how will we calculate it? Again, the last rank we used was 6. So this we will rank it as 7 and this will rank it as 8. Now average it. 7 plus 8 by 2 is equals to 15 by 2 is equals to 7.5. So we give the rank to 52 and 52 both the values to be 7.5. Okay. So The last rank which we used was 8. Now we, for the next highest value, we will use the rank 9. Okay, we need to remember this, which is 50, we use the rank 9. And the last value, which is 29, we use the rank as 10. Okay, now we do the same thing for yi too. So for yi, we have two tied cases, which is 65 and 65 I can see, and 52 and 52. We do the same for ry, and then we do calculate the value of di is rx minus ry. We calculate the values and fill up the column. And then di square, we calculate, we square these numbers. Minus 1.5 whole square is equals to 2.25, and like this we calculate all the values. And then summation of di square is equals to 64. All right, now we see there are two set of ties in x series. All right, we know that 94, 94, 94, and 52 and 52. All right, two sets, 94 and 52. 94 comes 3 times and 52 comes 2 times. So for this, how will you calculate the tx? Tx is equals to 1 by 12 summation of t cube minus t. So t is the number of tight cases basically. So is equals to 1 by 12 into 3 cube. For the first one, 94, 3 cube minus 3 plus 2 cube minus 2. Okay, for the second case, which comes 2 times. Okay, the answer comes here 2.5. And for ty, there are two sets of ties again in y series, which is 65 and 52, and both the number comes 2 times. So the value will be 1 by 12 summation in 1 by 12 into 2 cube minus 2 plus 2 cube minus 2. Okay, because both the value comes 2 times, then the answer is 1 for ty. Then we put the values in the original formula, which is rho is equals to 1 minus 6 into summation of di square plus tx plus ty divided by n cube minus n, which is equals to 1 minus 6 into summation of 64 plus c, 2.5 plus 1 divided by 10 cube. 10 is the total number of elements. The total number of candidates were 10 only, right? So 10 cube minus 10, and then we get the answer to be 0.6. The ranks on both mathematics and statistics are moderately correlated. So if someone is getting good in mathematics, may or may not get good in statistics. All right, so that is all for our today's class. We have covered many topics, many questions, and all of the questions are very helpful and very useful for your preparation. Okay, let's recap what we covered today. First is correlation coefficient r, measures relationship strength. And next is regression lines for prediction y on x and x on y. And third is, given regression equations, we find out the means and the r is the correlation coefficient. And the last thing we did is the rank correlation for rank data with and without ties. So these tools are foundational in statistics, economics, data science, and research. Okay, so I hope this step by step guide helped clarify them for you. So if you find this video helpful, please like this video and comment below if you have any doubts, and you can always reach out to me in my Instagram channel. And yes, thanks for watching and see you in the next one. I'll be coming with a new video soon enough. Okay, bye bye. Thank you.